Awesome. Thank you, Catherine. It's good to actually be doing this live. I know when we did a similar presentation last year, we had to get like cameras sent to us, and it felt like we were like a part of a studio, which sort of let me live out my like not really a dream of becoming an actor, but it was sort of cool. But I'd much rather be live and in person with you. And so I'm also super excited to be joining live and in real time my colleague Aaron. And we're here to be talking about how Looker fits into the modern data stack. So this is actually a part 2. We did a modern data stack presentation last year for Join. And now we've made the second edition here for Beacon. And so the whole premise was to kind of crowdsource some questions in advance from different customers and different people, and then try to figure out what were hot topics that we could discuss almost in like a podcast type format. So that's what we'll be doing today. So a couple of housekeeping things, just in terms of agenda. We obviously have our introductions. So I'm Phil Hall. I'm a customer engineer, part of Looker and GCP, and we'll have Aaron introduce himself here shortly. We sourced 3 questions in advance that we want to kind of talk, and we pre-prepared a couple slides to address, and we'll open it up to question and answer. So with that, Aaron, if you want to introduce yourself.
Absolutely. Hey, everybody. My name is Aaron Wilkowitz. Also a customer engineer with Looker. Been with Looker for about 4 years. And in particular, I specialize in kind of the healthcare and life sciences space. Very much looking forward to working with Phil and kind of talking through some of the questions folks sent in. And thanks again to some folks that sent us some questions earlier. So this is really helpful.
Awesome. So yeah, introductions. I guess we did that a little bit early. So yeah, Phil, Aaron, nice to be joining all of you today. And then as we dive in, before we get into some of these questions, I did just want to take a quick step back and present to everyone just a very quick refresher on what exactly Looker is, because I think it's going to be really critical for applying the right context as we start addressing some of these questions. And so again, when you think of Looker at a very high level, you think at the lowest layer, you have your data. That data all lives somewhere, and it probably lives somewhere that speaks SQL. Looker sits on top of that and defines how that data ultimately should be used. So how do you join the right tables together? What's the right way to do particular calculations and measure KPIs? And then give you the flexibility to take that data, turn it into information, and then turn that information into insights and consume that in whatever way your end users might want to. Whether that's traditional like BI when you think of reporting and scheduling, maybe you want to open up things more to be a little bit more self-service where they can ask more ad hoc questions, alerts, workflow integrations, and then even getting as far as APIs and custom apps. But I did just want to start with that just to make sure that when we think about where Looker fits, we can at least start at this broader high-level concept of you're moving data somewhere, that data lives somewhere. Looker is that reusable layer to tell everybody how to use it. And that's going to be really important to keep in mind as we start addressing some of these other questions. So without further ado, I will move to the next slide. And we have, drumroll please, question 1, which is, I love Looker, but we have several departments who already have tool preferences. What is the best way to accommodate some of these other departments using Looker? Aaron, what are your thoughts on this?
Yeah, I'd love to take a first stab, and then Phil, I'm curious if you want to kind of chime in here and add some additional color. I mean, what I would say is that every department has their favorite BI tool, right? Every department has the special way they want to visualize something, the knowledge of exactly how they want to do something a very specific way. Looker is not necessarily trying to bump up against some very particular visualization habits that folks have. Instead, I think what Looker is trying to solve is actually something earlier in the data stack. So when we think about like a typical data stack for supporting a BI tool, the kind of analytics you want to do in a BI tool, typically you start with kind of the raw data in a data lake or across a set of kind of data warehouses. And more often than not, that data gets processed, into a series of different kind of stages, right? So from like core to staging to enriched, there's a lot of other ways to kind of slice and dice the data process. But eventually the data goes into usually a data warehouse. And then from there, there's a series of cubes and extracts to prepare just the right data set to help a department, ask the question that they're interested in. That's kind of what we typically see. And I think Looker really kind of brings in sort of a new approach, to that. So Phil, do you want to take on the next slide here?
Yeah. And I think one thing that's really interesting too is while this looks like a relatively simple flow of landing the data, standardizing the data, and then staging it to whatever those analytical needs might be, what we've often witnessed as we kind of dive a little deeper into this staging layer in particular is you have all of these different ETL and these staging jobs that are using sometimes even semi-redundant logic where you have different teams writing different scripts that are doing almost the same thing, but just in slightly different ways to be able to curate that layer for those other tools to use. And so when you think about what some of those core tenets are of Looker, especially when we go back to that very first refresher that we gave of how do we have a consistent definition of how we make these things reusable, we often see Looker slotting into that workflow and actually replacing that staging and that enrich zone. Because you already have all of those standard tables, those standardized data sets within core. You know the data's clean. You know that a 2-digit state code in one table is still going to be a 2-digit state code in the other table. You have that basic rules already done. But we really just want to say, how do we impact all of this together? And that's where Looker can fit in because we are that roadmap that says, how do we join all these things? What is the right way to make these definitions? You don't have to worry about having a bunch of disparate scripts maybe made by different teams or different silos that are contributing to that. And for people who want to use Looker for their dashboarding and BI, great. You can log directly into Looker. But we definitely can augment and cohabitate with other tools if maybe there is a preferential selection of some of these other areas. And we can do that in multiple ways. So one, we can do that via just our API access. So if you maybe have someone who isn't using a traditional DI tool, maybe they love Jupyter Notebooks, maybe they're obsessed with R, maybe they're a front-end developer and they like using React, they can tie into those definitions and those transformations in Looker directly in a live view. There are also ways that we can help integrate with other BI tools using their version of like a custom web connector that can essentially use that same API process to generate extracts using this Looker interface that helps accelerate all the different joins and abstracts some of that complexity that might exist within the data. But we also have worked a lot really recently in the past 2 years of our product releases to be able to actually materialize result sets back to the database where we've made a lot of these definitions. And so you can think of this as saying, hey, I had one person who knew that table A needed to be joined to table B in this way, and they wrote an ETL script. Within Looker, we already know that that's how those tables should be joined together to reach that particular task. We can then write that back to what we might actually consider a publication zone here, where we might be denormalizing some of those tables, creating exactly the way those data structures should look to be consumed by those other tools. And then those other tools can process those without even needing to know that Looker was potentially doing that writing. So really just trying to have a very agnostic approach of at its core, we want to help you understand how data should be used within the organization and then be able to surface that across a variety of tools depending on what's going on with that. Aaron, did you have any other, I guess, final thoughts before we?
Yeah, I mean, I think the only thing I would add there is in many ways, Looker is playing a different game than what a lot of other kind of BI tools are playing, right? And maybe, one of the call outs I want to make on this slide is you can see that connection between Looker and, tools like Power BI and Tableau. So if you want to use Looker to feed tools like Power BI and Tableau, that's totally fine, right? In a lot of ways, the visualizations that any of these tools are providing are being commoditized, right? The value is not in kind of the final display. There's so many ways to do that now. The value is, how do I get my data to be written or query my data in a governed way and to describe these really complex rules in a governed, reusable way? That's the primary value of Looker. And that's what helps it kind of integrate in with these other departments.
Awesome. Cool. Well, I think that about covers it then for the first question. Aaron, what do we have next?
Yeah, so this question, near and dear to my heart, we're starting to invest more into data science. Can Looker help? Short answer is yes, but Phil, do you want to explain a little more detail how?
Yeah, absolutely. So when we think of what generally needs to happen to be successful in a data science environment, first step is always, how do we actually define that data, and how do we make sure we have the right data to inform what we're ultimately trying to predict on, or if it's prescriptive analytics, how do we actually get that data in the right place? There's always going to then be a profiling step. You need to be able to generate these hypotheses to say, oh, maybe if I'm trying to predict if a TV show is going to be better or worse, at least from a rating generation perspective, what things should I look like? Maybe I have a hypothesis that if it's slotted at 7 p.m. on a Monday during prime time, it should generate better ratings. Maybe if it's fantasy, I think fantasy is going to generate better ratings than sports. There are all these hypotheses that come into that. And that first phase is just very critical, and just being able to get access to those right insights so you can start hypothesizing. Once you create those hypotheses, you often need to train the model. You need to figure out what features are going to be most important to feed into that to get to that outcome. You then need to see if that model works correctly. And then you actually eventually need to deploy and put that into production so you can actually start making value out of it. And I think what we're about to see, and Aaron, I know you have some personal experience with this as well, is a lot of the times people really get stuck on this define and analyze, or they're deploying things to production and they might not have gotten the necessary feedback loops to be able to actually ensure that what they're building is going to be effective for the different business units, the different departments that they're trying to go after. So with that, Aaron, I'll hand it over to you, and maybe you can give me some of your thoughts, because I know you've done a lot of predictive analytics in your past.
Yeah, I was going to say that. Yeah, I spent about 5 years at a predictive analytics software company, and there were kind of two challenges that emerged that I saw. The first is that there are a lot of problems with just getting the data cleansed, getting the data prepared. So, in looking at kind of a traditional data science workflow, typically the way that these things operate is that, you're doing probably a little bit too much in the data science tools like Python or in R. You're trying to take in the raw data and prepare it, clean it, prep it, transform it, then run your predictive model, which is what those tools do really well, and then try to create some sort of output that the rest of the organization can benefit from. And that can be really challenging, right? Because those tools were not always made to prepare data. Those tools weren't always made to make a lot of new inputs. So just as an example, I work with a lot of hospitals. They're trying to predict how many patients are going to get readmitted into that hospital. How long will patients stay on average? If COVID surges by 50%, will they be out of beds? Right? These are the kinds of questions they have to predict ahead of time. And the best way to build better predictions is to have good data and to have more sort of inputs to act as correlations to predict how accurate your data is. And that ultimately is a data problem, and one that Looker is really well poised to solve by bringing in more of those inputs, making it easier to create governed rules like, yes, no, this hospital has an emergency room. Yes, no, this hospital has a triage unit. The growth in the hospital's number of patients is up by 30% or 50% or 70%. There's all sorts of inputs that you can help add into Looker that make the predictive model more accurate, and more sustainable over time.
Awesome. Yeah, and I think that speaks really well to your point, how Looker can help accelerate that, because you, again, go back to that very first slide we mentioned in that refresher of how do we ensure that we know the right ways to relate all of these different data sources and calculate these metrics. Aaron just cited a bunch of amazing, I think, examples in a very practical way of these things that could really shape an input of being able to do these types of predictions. And actually, that just made me think of a pretty practical example in some of my past experience where I was part of an analytics pod and I was the data engineer. And then I had a data scientist on my team. And I remember it being like on a Monday, and I walk in and the data scientist is sitting there and he's cursing under his breath. And he's like, grumble, grumble, grumble. And I'm like, dude, it's Monday. It's not even lunchtime. Like, what do you have to be so upset about right now? And he was like, oh, well, I got to rerun this model in R. It's going to take like 6 hours. And I was like, well, why do you need to rerun it? And why is it going to take 6 hours? He's like, well, I have to rerun it because I just made a really simple mistake in the way that I was tuning the model, and I know that it's not going to work. But the reason why it's going to take 6 hours is because the query that I wrote to pull in the data into R takes 3 hours to run. And I was like, that seems a little bit extreme. And I looked at his query and I added a where clause that still met his goals, and the query ran in 30 seconds. And so I think that's just a really key way to where we can ensure that those data science experts are staying in their domain. They're building those models. They're figuring out applications for those models. They don't have to worry about what's the proper way to actually surface that data to ingest in those tools. And because Looker really covers that ability, and we do surface a bunch of different ways, like we highlighted in that very first question, to consume those insights beyond just logging into Looker, that gives those end users and those data scientists the choice to say, okay, I'm going to hit this API call, or I'm going to schedule data out to whatever my workflow is, and I get to focus on why I'm getting paid $150,000 to $200,000 a year, as a lot of data scientists are, which is to actually build impactful solutions. And then from there, because Looker is sitting on top of those outputs, we have a lot of flexibility to then make those outputs actionable, or as opposed to just sending maybe a screenshot of your output in R or your output in Python and just sharing that knowledge or putting it into a deck. We can use a lot of the other capabilities of Looker to actually make sure that whatever that data scientist creates isn't going to be lost as they continue to make that operational, and they actually start pushing that out to the business units. So that, I think, is a really good way of, I guess, how Looker can help with like the end-to-end life cycle. But as we mentioned in the very first slide, there's still a lot of work that goes into creating those hypotheses and figuring out what are maybe the relevant inputs to even feed to that. And so one of the great things about Looker being able to be now a part of the Google family and having access to all of the powerful Google technologies that exist around machine learning and data science is, well, actually, I feel like I've been talking for too long. So Aaron, I'm just going to pass it off to you and you can talk about that.
About BQML, that is?
Yeah.
Yeah, absolutely. Yeah, so a lot of exciting things coming down the pipeline between Looker and Google. Google is obviously an industry leader in cloud-based, serverless, managed predictive analytics. And one of the most exciting is something called BQML, or BigQuery machine learning. Phil's example is an awesome example of some of the challenges that result from data scientists having data engineering challenges and vice versa. And BQML is a really fascinating way of trying to bridge the gap between those challenges. It's basically a SQL-based approach to machine learning. So inline in SQL, inline in BigQuery, you can run machine learning algorithms, to predict and train your models to do a better job of understanding, what's going to happen in the future and predicting what will happen in the future. And the benefit of that is that if it's inline in SQL, then having a tool like Looker that can write natively in BigQuery SQL opens up all sorts of new possibilities. So again, enabling kind of that data engineer to begin dabbling in data science, right? Or allowing the data scientists to not have to worry about ever opening up a Python notebook or an R notebook, but instead just having a SQL script, or even better, a Looker-based semantic layer that can describe BQML and sit directly on top of BQML opens up all sorts of new possibilities for efficiently getting really powerful predictive analytics. And so with that, I want to turn it back to Phil to talk a little bit about kind of going back to the idea of rapid prototyping, but now with Looker under the hood.
Yeah, and so Aaron, I think one thing you forgot to mention is the timeliness that all of this can actually enable, and how agile and quickly you can start actually turning this into different decisions. And so one of the things that I think has been very interesting is this has allowed us to actually start doing these 2 or 3 hour workshops and being able to get these data science and these predictive analytics prototypes very quickly. So you heard me mention an example earlier about how do we better predict TV ratings. And that wasn't just a random musing by me, although sometimes I tend to do that. This was actually a practical workshop where we had a local TV station who came to us and said, hey, help us predict what the ratings of what these TV shows and this programming that we're putting out on the air are going to be, so that we can maximize the amount of money that we can earn from selling ad time. And so we got together and we got all these data scientists. We started doing these prototypes in BQML using Looker because it was really quick to just iterate and start getting to some of these things. And we were quickly able to find out, we can predict ratings with a 30% margin of error. One of the key features, top 2 features of this prediction was the time of day, and then separately, the day of the week. And so that sounds great. We got a really nice error ratio for like something that we just spent 2 hours on. That sounds like a win. And it was a win, but it wasn't for that particular reason. The reason why it was a win is because we gave the data scientists the ability to quickly show the business, who was also invited to this workshop, this is what we did, and we think we're pretty cool. And then the business was able to say, oh, I mean, you are pretty cool, but like, that's actually not right. One, even though this has a good margin of error, we noticed that your predictions are actually consistently higher than what the actual ratings were. And just getting the rating right is not how we make money. We make money if we come within 90 and 100% of what we told some of the ratings were, because we promise these people a certain rating. They pay us for that promise in terms of advertising. And if we fail to deliver on that promise, then we have to give them credits for free that they can use to buy future ad time. On the other side of that, if we end up consistently over-delivering, there's no benefit to us outside of them being really happy because they got a lot more exposure to their ads than they ever thought. And so that provided the ability, because they were able to quickly just create an MVP and a prototype of how we can help them predict those ratings, to say, oh, we were actually trying to predict the wrong thing. We shouldn't have been trying to predict the rating itself. We should have been trying to predict like a classification of makes us money, loses us money, and then missed opportunity. And we want to make sure that we optimize accordingly for that as opposed to the other thing. The other thing that they said was you can't just take the time of day and the day of week in isolation, because people are going to watch TV on a Saturday at way different hours than they're going to watch TV on a Tuesday. So you almost need to take those as one particular feature when you build these models. And the beauty of this was not necessarily the ability that we made this amazing model. It was that in a matter of 2 or 3 hours, we had this consistent feedback loop that allowed everybody to actually get to where they wanted to go and drive an impact on the business. So I hope that answered our data science question. Thank you again for submitting some of these in advance. We're going to move on now to question 3, as we're running a little short on time, and we want to make sure that we have time for Q&A here. So this question is, how should we design our data stack to support both internal and external sharing use cases? So just to provide a little color, some people use analytics to figure out how can I make my business better, but there's a lot of companies out there that have valuable data and they want to be able to share that data with other people. Maybe that's a CPG sharing sales back to their advertisers, so advertisers have more inputs into figuring out where to optimize that spend. Maybe it's, to take Aaron's example, a hospital who wants to be able to share information back to insurance companies. Maybe you just have a bunch of valuable data and you want to be able to share that with a whole bunch of people. So this is a really common use case for Looker. And Aaron, why don't you give a shot at how our customers generally approach this?
Yeah, absolutely. So, when I think about this, we already talked a little bit here was about how, Looker's inputs, we try to be as agnostic to as possible. We write to 60 different dialects of SQL. If you can write something in SQL, then Looker can write to it. So we want to be input agnostic. And as much as possible, we also think of ourselves as a data platform. So we want to be output agnostic as well. Where basically we want to provide you the flexibility where, of course, if you have dashboards that you want to provide, to an end user in a BI application, sure, no problem, we can do dashboards. But we go far beyond dashboards too. Whether it be, sort of presenting Looker experiences to end users via iframes, or via dashboards that can be rendered via iframe or in the JavaScript itself. Whether it be, little bits of knowledge and data. Sometimes an application, all it needs is one little number, for somebody to know, do this or don't do this, right? And that number might have come from a very, very complex Looker model that goes through all of this work to use an API call to send that one thing out. We also have a lot of interactivity between kind of that content that displays and renders in an iframe or in JavaScript and our RESTful API calls, that allows for totally custom workflows and actions, and enables kind of custom application development. But I would really think of Looker very much as a platform and as something with developer toolkits and meant for kind of those end users. So with that, I want to turn back to Phil to talk a little bit more about kind of multi-tenancy and single tenancy implementations with those customers.
Yeah, and I think one thing that's interesting there is we go back to the question of how should we design that data stack? And our answer is often whoever's easiest for you. If you're collecting, maybe like we have a customer who sells a bunch of devices and there are agents on those devices and they send them to all the same database, leave it all in that same database. We're going to be able to help make sure that only the right data is surfaced to your customers in that context. But maybe that same customer wants to send information to separate databases. Maybe they're a little bit more security conscious and they want to actually have that data physically siloed. You don't need to consolidate it for Looker to work with that either. We really want to be agnostic to how you're storing your data and how you want to use your data, which is what makes us such a great fit for these types of use cases. So to directly answer the question of how should you worry about setting up that data stack, a lot of the times it's going to be start with what's easiest for you and what's most natural, and we can iterate and make changes over time. But just to kind of dive into some of the capabilities of Looker and how we enable this is, again, whether you want to choose to take a multi-tenant approach and having all of your data living in the same place across your customers, or a single tenant approach, Looker knows who's logging into the solution, whether that being a solution that you're hosting or that you built yourself, and it knows who's logging into the solution directly if you just choose to do more of an original equipment, like OEM type deployment. And we can use that to apply dynamic rules when they curate the data. So we can pretend that Aaron, I'm going to pick on him because I know he's from the DC area, is, let's say, a member of the Washington football team, and then I'm living in Chicago, a member of the Chicago Bears, and I want to log in to see all my different sports analytics data in this portal. With Looker, we can say, all right, Phil's logged in, apply a filter so that Phil only sees Chicago Bears data. When I share that same dashboard or that link with Aaron, it's going to be like, oh, this is Aaron. Apply this so that we only see the Washington football team's data. And all of that can be done on the fly, literally just based on who is actually accessing the tool. And so this is just a little bit of snippet of how that works. There's a lot of different ways. But when we think of the LookML and the way we model this data, it's literally just putting in these exploration environments that are driving these visualizations. Let's just tie the attribute that we need to apply that filter to the attribute of the user and say they're only allowed to see what they're allowed to see. And because it's done in that really simple tag, it has broader extensibility for as many customers as you want to potentially go out to. The same is true if maybe Aaron gets his own database and is like, hey, like we have a bunch of proprietary football analytics. We don't want even a chance of that data living next to especially Chicago. Like they're in the same conference. We don't want to even consider that. Okay, great. We're going to put all of Aaron's Washington football data in one database and then all of my Chicago data in another database. But ultimately, Looker, again, doesn't care where that data is stored. And because it's the same type of data, that schema, those naming conventions, and the logic for analyzing that is most likely the same. So again, we can take who's logging into the platform and just simply take that same logical structure and plop that on top of that additional database. So when Aaron logs in, he's using the same logic, but it's only for his database. And then when I log in, I see the visualization, but it's only on the data that's within my database, and we can parameterize those things. And so that's, again, just an example here of how that can be implemented. We can either point to a different database or a data set in the same project, or we can actually change the connection string to potentially point to a different server or a different database to make sure that regardless of how you set up that up, we're going to be able to provide analytics and expose that to your customers. So that's like a very technical, tactical example of how you could set up your data stack. But I think what gets lost a lot of the times is how do you actually ensure that what you're building is what the customers want? And so, Aaron, I know you have a lot of stories on that subject.
Yeah, absolutely. Yeah, I mean, the most important thing is really making sure you have a really good feedback loop system, right? So you think you know what a customer wants, you think you know how to build kind of the embedded content that your users want, but sometimes they don't even know what they want. And the real way to test it is to say, well, what queries are these users actually running? What dashboards are they looking at? You know, what of your API calls are they hitting more often than not? You know, there are certain tenants, you know, the Chicago Bears asking totally different questions than the Washington football team. And the beauty of Looker, in particular, our system activity, is that we track every single piece of content and every single user action. So you have full control and visibility and transparency into everything that your customers are doing. So you can build those feedback loops, more efficiently, and kind of be off to the races.
Yeah, awesome. One thing just to add there, and Aaron, I know you got to jump to another conference. He's just like the conference king. Like he's just got obligations all over the place. But one thing I think just to kind of put a cherry on the top of that given subject is this enables, one, the field team to understand if maybe certain aspects of the products they're building are being used more frequently or not frequently, and then what content is being used and who's using it the most or not the most. So just common things that we often address is, do you actually need to invest in training these people? Because there are certain groups of users who log in and they don't do anything and they never log in again. Were they intimidated, or were they just users who were never going to be users in the first place? We might not be able to answer those questions, but we're at least able to alert you to when those scenarios arise, so that whether it's your product team or that sales team or that field team, you have the ability to get to that and start having these feedback loops start presenting themselves organically. And then one of the other things is we often see people using maybe a different internal tool for analyzing what they think customers are doing, instead of using the same tool that they're presenting out these information when they're sending data externally or sharing that with other parties. And that's something we definitely want to encourage and have you avoid, because again, Looker is the single source of truth. We're documenting how people should be consuming all of these insights. So if you use something else because you just happen to be used to it and it's not on that same rule set, and a customer comes to you with a question or support, you want to make sure that your support teams are using the exact same logic, have the ability to pseudo or impersonate those customers to ensure that you're actually empathizing and living with the exact experience they would, as opposed to living in potentially disparate sets of information. And so with that, I think that wraps it up. I saw Aaron drop, so a thank you to Aaron for joining me today.